Okay, so here we are in part 2. These questions are tricky. These are pretty tricky. Let's try it. So basically it says if then. All these questions in number 1 and number 2 are if then questions. And the way if then questions work is you must, oops, let me get that straight here. You must make the if work become true. Then test the then part. Right? Because if somebody makes an if-then statement, if I say, if it's got 4 legs, then it's a dog. Now that's not a true statement. Not everything with 4 legs, it says legs, is a dog. There's cats and there's horses and there's other things with 4 legs than dogs. So if I say, hey, if I see something that has 4 legs, then it's a dog, I'm not right. That's a crazy statement. But how do you prove I'm not right? How would you show it? You would have to find something with 4 legs like a cat, right? You got to meet my if. See, it wouldn't work to say, look, there's a person. They have 2 legs. They're not a dog. That wouldn't prove I'm wrong. Even though I am wrong, that wouldn't prove I'm wrong. Because I said anybody with 4 legs is a dog. I didn't say anything about people with 2 legs. So you see what I mean? If somebody makes an if-then statement, logically, you've got to meet their if. So you've got to find something that has 4 legs, like a cat, that's not really a dog. You've got to meet their if, and then see if the then follows or not. That's the very nature of an if-then statement logically. You got to meet their if. They're saying if such and such happens, then this follows. So you got to meet their if, and then find out if what they said follows or doesn't. So let's take a look. So if D divides A squared, so you just got to pick numbers that work. You got to make the if work. So how about if D is something like 2, try to pick little numbers, and A is something like 4. 2 goes into 4 squared, right? If 2 goes, that's 2 into 16. 2 does go evenly into 16. I made the if work. Then the D will go into the A. 2 into 4. 2 goes into 4. That's true. Now, careful. This statement actually is false. Now, I'm probably just confused you. Why? 2 goes into 4. That's true. Yeah, it's true for these numbers. It's true for D2A4. But when they make this statement, if D goes into A squared, then it goes into A, they're saying it's true always. For every D and A, for every D that goes into A squared, it'll always go into A. That's what they're saying. Just like if I said, if it has 4 legs, then it's a dog. Right? I'm saying everything that has 4 legs is a dog, not just some things, right? Just because you find one 4-legged creature that is a dog, that doesn't prove my statement's true. I'm saying if you got 4 legs, anything with 4 legs, then you're a dog. That's what they're saying. They're saying anytime you meet this if, anytime at all, the then will follow. I happen to find one particular case when we met the if and the then did follow. Yes, it did follow in that case. But how do we know it's going to follow in every case? Well, that's the difficulty. That's why these are really hard. These are probably some of the hardest questions on the test. Whenever you get true, what I would do on the test is just circle true, move on with the rest of the test, and if you have time at the end, come back and take a second look, because there might be another case that's false. There might be something else with 4 legs that's not a dog. So I'm going to do it right now, though, because I'm teaching this stuff. So let me show you another example. What if instead you switch them? You let the D be 4 and the A be 2. Let's check the if. You got to make the if work. If D goes into A squared, does it? Does 4 go into A squared, 2 squared? Yeah, that's 4 go into 4. Yeah, that's true. Okay, I met the if. Then they're saying if you meet that if, which I did, 4 goes into 2 squared, the then will follow. Well, D goes into A. Let me see, what's that? 4 goes into 2. No, 4 doesn't go into 2. 4 is bigger than 2. See, the then didn't follow. I found a case where for D4 and A2, 4 goes into 2 squared, D goes into A squared, but D doesn't go into A. So it's not always true, is it? It was true up here in this case when D was 2 and A was 4, but it's not always true, as we see right here. Here D goes into A squared, 4 goes into 2 squared, but D doesn't go into A. So this is a statement that is false sometimes. It's not always true. Just like my if it has 4 legs, then it's a dog. Of course, some four-legged creatures are dogs, but not every four-legged creature are dogs. This is a false statement, and this is a false statement. So you got to keep trying numbers, different numbers, until you can break it and make it false. Now, if the statement's really true, then it's going to work for all numbers. That's what's difficult. So again, I would just do the problem once. If you get true, bubble true, go on with the rest of the test, come back to it for just to the true ones, and try to find some more examples that maybe break it. Okay, let's try number 2 here. If D does not divide into A, then it will not divide into A squared. Okay, so we got to pick it. So you want if D does not, or I'll write not, does not go into A, then D will not go into A squared. Okay, so you gotta remember what we gotta do. We gotta meet the if. So pick a D. D would be like, how about 3 does not go into, I don't know what, 4. 3 does not go into 4, right? So I met the if, that the 3 does not go into 4. Then, so the D I picked was 3. It will not go into 4 squared. Does 3 not go into 16? 4 squared? Yeah, that's true. It does not go into 16. So in this case, I met the if, and the then did follow. If 3 doesn't go into 4, then it won't go into 4 squared. That was true. But here again, this is one of those that's not always true. It's sometimes true, but not always true. I know these are hard. These are the separate the A's from the B's questions. These are the hardest questions on the test probably. Because here's another example. What if you pick D? Again, we'll start here. What if I pick D to be 4 again? D is 4. Okay, let me write it again. So if D does not go into A, then D will not go into A squared. If I pick D to be 4, that does not go into 2, and A to be 2, right? That meets the if. 4 does not go into 2. It's bigger than 2. Then D, what was my D? My D was 4 here. D4 will not go into, what's my A? 2. 2 squared. 4 does not go into 4. Yes, it does. So this is a false statement. You see, it was true sometimes. It was true here, but it's false here. And if to be true, it's got to be true always. So if you find any numbers that make it false, then it's false. Just like my statement, if it's got 4 legs, then it's a dog. That's true sometimes, of course, but not true always. So an if-then, logically, has got to be true always. If there's even one time it's not true, we say false. Because it's not a true statement to say everything with 4 legs is a dog. It's not a true statement to say if D does not divide into A, then it won't go into A squared. Sometimes it does. 4 doesn't go into 2, but it does go into 2 squared. So that's not always a true statement. That's false. All right, number 3. Part C. Bring it up here. If D does not go into A squared, then D does not go into A. All right, if D does not go into A squared, then it won't go into A. Let's pick some numbers. How about if I go 3, let's say, how about I go 9? Well, I want to pick easier numbers. How about 4, does not go into, and I'll pick A to be, and D to be 4, A to be 2. So if 4 does not go into 2 squared, no, wait a minute, that's not a good example, is it? Remember, you've got to make the if work. 4 does not go into 2 squared. 4, yes, it does. So that I didn't make the if work. They said pick a D that does not go into A squared. 4 does go into 2 squared 4. So that isn't a good example. You've got to meet their if. Like if I say if it's got 4 legs, then it's a dog. You got to show me something that's got 4 legs and not a dog. So that won't work. How about 3? If 3 does not go into 2 squared, that's true. 3 doesn't go into 4. 3 doesn't go into 4. Then that same D, 3, will not go into just the plain A, 2. 3 does not go into 2. That's true. This one's true. This one's going to always be true. You could do example after example. It will always be true. If D does not go into A squared, it'll never go into A. It's a true statement. So I'm going to go on for D. Okay, now for D, we're talking about the LCM. I think we got to be super clear, first off, what the LCM is. What's the LCM of two numbers? So the LCM of A and B. So let's say, what if they say, what's the LCM of 4 and 6, for example? Well, you got to break the 4 down, 2 times 2, the 6 down, 2 times 3. Then you write 4 is 2 squared, 6 is 2 times 3. And remember how we do LCM? It says lowest common multiple, but you actually you do the opposite, right? Remember that from the last section of the course? You take the highest power here, which would be 2 squared, and the highest in the next column. See how I lined up the primes, the 2s, the 3s? The highest 3 is just a single 3, so that's 4 times 3, that's 12. 12 is the LCM of 4 and 6. And that makes sense. 4 and 6 both go into 12, don't they? That's the lowest number they both go into. They also go into 24 and 48. But 12 is the lowest number 4 and 6 go into. If you were adding fractions, 1/4 and 1/6, the common denominator, the least common denominator, the LCD, would be 12. That's what LCM is. By the way, since we're doing this, let's do GCD at the same time, because that's the next thing. How do you do GCD? What would be the GCD for 4 and 6? Remember, it says greatest, so we actually take the lower when it comes to primes. You take the lower when you do the prime breakdown. You know what I mean? So I broke 4 down to 2 squared, 6 down to 2 times 3, and then for LCM, lowest, I take the highest number of 2s and the highest number of 3s. For GCD, I take the lowest number of 2s. What's the lowest? A single 2. What's the lowest number of 3s? None. No 3s at all. Right? Because he has no 3s at all. So it's just 2. The GCD would be 2. And 2 is the number that goes into 4 and 6. That's what GCD is. All right. Let's do one more. Let's make sure you're clear on that. So let me pick another number. So I'm going to do like A is, I don't know, 40. How about a bigger one? And B is, 12. Okay, let's do the LCM GCD thing. So if I break this down, 4 times 10, 2, 2, 2, 5. And this is 4 times 3, 2 times 2. Okay, and so now 40 is 2 cubed times 5, right? 3 2s and a 5. 12 is 2 2s and a 3. So LCM, what's the LCM going to be? Well, it says least, but you take the high, when it comes to the primes, you take the most. So most number of 2s, 2 to the third. Most number of 3s. So I gave every prime its own column. Most number of 3s is a single 3. Most number of 5s is a single 5. Let's add 120. If you use your calculator, it's 120. And now the G, go down here and do the GCD at the same time. The GCD, greatest, you actually take the lowest number of 2s, 2 squared. The lowest number of 3s, none. The lowest number of 5s, none. So that'd be 2 squared, 4. 4 is the number that divides into 40 and 12. That makes sense. 4 does go into 40 and 12. It's the greatest number that goes into them. And 120 is the lowest number that they fit into. 40 and 12 both go into 120. So that's how we do that. So let's get back to the question now. That's what they mean when they say LCM or GCD. Okay, so now they're saying, okay, for all numbers A and B, you pick any numbers A and B you want, and the LCM will divide into A. This means A times B, doesn't it? There's no symbol in the middle there, A times B. So let me just pick an A. I don't know. How about 2? Or how about 4 and 6? Let's go back to the, well, I'll do something different. How about 6 and 8? Whatever. Just picked a couple of numbers there. Or how about 6 and 10? So, okay. So I'm going to break down the 6. 2 times 3. Break down the 10. 2. And I'm going to write the 5 over here. Remember, every prime gets its own column. So what would be the LCM? It says least, but you take the most number of 2's, which is just a single 2. The most number of 3's, which is a single 3. The most number of 5's, which is a single 5. That's 30. 30 is the number that 6 and 10 go into. That makes sense. That's the lowest number 6 and 10 goes into. Okay, so what they're saying is for any numbers, for all numbers, like 6 and 10 or any numbers, the LCM of those numbers will go into A times B. Is that true? Let's see. What's the LCM? I just figured out the LCM was 30. Does that go into A times B? 6 times 10. Does 30 go into 60? Yeah, that's true. It goes into 60 perfectly twice. That's true. This one's always going to be true. Let's go on to E. So for E, it says, if the GCD of two numbers is A, then A goes into B. So if the GCD of two numbers is A, then the first number goes into the second. Well, let's find an A and B that meets the F. So how about if A is 4 and B is 6? Let's do that again. So 4 is 2 squared. 6 is 2 times 3. So the GCD, now this says greatest, so we actually take lowest. Lowest number of 2's is 2. Lowest number of 3's is none. So it's just 2. It's just 2. So the GCD of those is 2. So did I meet the if? They said if the GCD of the two numbers is the first number. So the GCD, what are my two numbers, A and B? 4 and 6. It's equal, I actually got 2. That's not right. Do you see how I did not meet the if? They're saying you've got to pick an A and a B such that the GCD will just come out to be the first number. My GCD came out to be 2. It's supposed to be 4. It's supposed to be my first number. So I haven't even met the if yet. I can't even think about the then on this problem because I haven't met the if. I have not met the if. You've got to pick, it says, if you pick a two numbers and the GCD is the first number, then something else will happen. Makes sense? So I've got to pick a new A and B. I've got to pick an A and B where the GCD comes out to be not that, but 4. It's got to be that first number. Well, how do you do that? Well, think about it. How do you have two numbers where the GCD is the first number? The GCD, remember what GCD is? It's what goes into the numbers. If I have a number like 2 and 6, what goes into 2 and 6? 2 does, huh? 2 goes into 2 and 6. Do you have the feel for GCD? GCD is what goes into them. GCD is what goes in. The greatest thing that goes in, right? So the greatest thing that goes into 4 and 6 was 2. That's the greatest number that goes into 4 and 6. And that's not the first number. But the greatest thing that goes into 2 and 6 is also 2, and that is my first number, so that'll work. So let's do that. Let me say that again, I'll show you. So right here. So I'm going to pick A, 2, and B, 6. Why? Because the greatest thing that goes into 2 and 6 is 2, which is my first number. That's what they're saying. The greatest thing that goes into them has got to be your first number. The greatest thing that goes into 2 and 6 is 2. Right? If I do GCD, well, here, let me just break it down. So for 2, if you break him down, there's just 2. There's nothing else to do. And 6 is 2 times 3. The GCD, which is the greatest, what's the greatest thing that you take the least number of 2's, which is a single 2, the least number of 3's, which is none, it's just 2. The GCD is 2. Maybe that more formal method isn't the best. Maybe you should just think, what goes into 2 and 6? 2. So the GCD of 2 and 6 is 2. It's equal to the first number. So I met the if. The if works. Then, they're saying when that happens, the first number, this is A and B, A will go into B. The 2 goes into 6. Does 2 go into 6? Yeah, that's true. This is a true statement. Okay, we're on F. If A and B are even, so you got to pick an A and B are even, like maybe A is 4, B is 6. If they're both even, then the GCD will be 2. So what's the GCD of 4 and 6? So if they're even, then the GCD will be 2. Is it? What goes into 4 and 6? GCD asks what goes in. What goes into 4 and 6? What's the greatest number that goes into 4 and 6? 2. Yeah, it equals 2. That's true. But here again is a trick. Remember, when you get true, that doesn't mean it's always true. Let's try some other numbers. What if A is 4 and B is 8? This is going to be more tricky. They're both even, right? They're even. So I met the if. I picked 2 even numbers. That's the if. Then they're saying always, whenever you pick 2 even numbers, I pick 2 even numbers, the GCD will always be 2. Is it? What goes into 4 and 8? What's the greatest thing that goes into 4 and 8? 4, not 2. False. So this statement is sometimes false. So we say false. It's not always true. Okay, if A divides B and A does not divide C, then A does not divide BC. So you got to pick an A that goes into B, like maybe 2 goes into 6. And 2 does not go into, I don't know, like 5. So I made the if work. I picked an A that goes into 6, 2 goes into 6, but does not go into 5. Then, let's see if then 2 will not go into B times C. What's B? B is, I picked B as 6 times is B times C, right? And C 5, 6 times 5. 2 will not go into 30. Oh, no, it does go into 30. That's a false statement. As soon as you get false, you just know it's for sure false, move on, don't even need to give it a second thought. It's only when you get true at first that you wonder, is it always true? Or should I try some more examples? Because maybe sometimes it's false. If you find false, you know it's not always true. Right here I found an example that's false. All right, let's try the next one. Let me get a fresh screen here. So if D divides into A minus B, so I got to pick a D. Let's see. 2 goes into A minus B. How about 8 minus, how about 9 minus 5, right? Because 2 goes into 4. So I picked a case. I'm trying to break it. I'm basically trying to pick weird numbers to see if I can prove it's false. So 2 goes into 9 minus 5, right? 2 goes into 4 evenly. And D goes into B. 2 goes, B is 5. Oh, wait a minute. You got to pick the second number. So it goes in. Okay, so that's not going to work. You see, the if is both these. It's and. I got to do both parts to meet the if, to make the if work, which you must make the if work in an if-then logical statement. You've got to make both parts true. So let's go back here. What if I'm going to have to do something like, I don't know, 8 minus 4. Because that'd be 4. 2 goes into 4. And 2 goes into the second number. It does, right? Because B is the second number. B is that number. So now I've met the if. 2 goes into 8 minus 4, which is 4. And 2 goes into 4. That's true. I met the if. Then, what was D? 2 will go into A, which is 8. Because 8, right? A is 8 here. Yeah, that's true. Yeah, this one's always going to be true. Let's go on to C. If A times B goes into C. Okay, let's go. 2 times 3 goes into, I don't know, how about 12? Right, 6 goes into 12 evenly. Then A, which is 2, will go into C, which is 12. Is that true? Yeah, 2 goes into 12. And 3 will go into 12. Yeah, 3 goes into 12 evenly. Yeah, that's true. That one's always going to be true. You could test more numbers. It's always true. Let's try D. If A goes into C, so I'm going to pick something like 2 goes into 6, and B goes into C, like how about 3 goes into 6? So I made the if true. You got to make the if work. 2 goes into 6, 3 goes into 6. Then A times B, 2 times 3 goes into 6. 6 goes into 6. Yeah, that's true. But this is one of those more tricky. It's true this time, but it's not always true. Let me show you. So let me write it out again. If A goes into C and B goes into C, then A times B is going to go into C. Here, I'm going to do something tricky here. If I pick these all to be the same number, if I pick A to be 2, 2 goes into 2. There's no, right, this is supposed to be true for all numbers, so you can pick the same numbers. 2 goes into 2, and 2 goes into 2. I'm looking A, B, and C all be 2. They said it was true for all numbers. So let's see if they're right. Is it true if you pick them all the same number? It would have to be if it's really a true statement. 2 goes into 2, and 2 goes into 2. I'm letting A, B, and C all be 2. Then 2 times 2 will go into 2. Whoops, see, it's 2. Right, they're all 2. 2 times 2, that's 4. 4 goes into 2. No, 4 doesn't go into 2. That's not true. That's false. Do you see how it's false sometimes? That's hard, I know. All right, let's go on to the last one of these crazy things. Let's go on to E. So if A divides into B times C, like 2 goes into, I don't know, 3 times 4. 2 goes into 12. That's true. Then, so I made the if work. The if is true. Then A will go into B. 2 goes into 3. No, it doesn't. 2 doesn't go evenly into 3. Or 2 will go into 4. Yeah, 2 does go into 4. And they just said or. So you don't have to do both, right? If I said you can apply for this scholarship if you've been to the moon or you grew up in Fresno. You don't have to do both. If you grew up in Fresno, you can apply for the scholarship. So an or statement means one or the other. So 2 does go in, even though it doesn't go into 3, it does go into 4. So that worked. That was true. But this is another one of those tricky ones that's not always true. Yeah, it was true in that case. One of the parts of the or statement in the then worked. But let me show you that it doesn't always work. If A goes into B, C, then A goes into B, or A goes into C. So here I'm going to be tricky, and I'm going to try to break it. 4 goes into 2 times 2, right? 4 goes into 4. Then 4 will go into 2. No, it doesn't. Or 4 will go into 2. So I pick B and C to be the same. That's not true. Neither one of those is true. 4 doesn't go into 2. 4 doesn't go into 2. 4 goes into 4, but it doesn't go either one of those. That's a false statement. Okay, John took all his money out of his account. Then he spent $110 on a radio. So if we let X be the amount of money he had originally, if he spent $110 on a radio, then, so I'm letting X be the starting amount. And then if he spent 110, now he's got, minus 110. He's got less. And then, after doing that, he spent 4/11ths of what was left on presents. Now, what does that mean if you spend, let me write down here, if you spend 4/11ths, then that leaves 7/11ths. Do you see why? Because, it's kind of like, say, if I eat 2/3 of a pie, that leaves 1/3, right? Because the whole pie is 3/3. Are you with me? So right, the whole pie is 3/3. If you eat 2/3, that leaves 1/3. Well, in the same way, the whole amount of money that John originally had, you could call it 11/11. It's one whole amount, like one whole pie. So the whole amount of money John had is 11/11ths. If he spends 4/11ths, subtract those, that leaves 7/11ths, doesn't it? See how we can always just take the rest, the leftover, and that's what they leave? So that means if John spent 4/11ths of this, right? So he started off with X, he spent 110, and then he took this amount, and he spent 4/11ths. That leaves 7/11ths, right? See why I put the 7/11ths there? Because 7/11ths of the remaining part of his times, 7/11ths times of his times, the remaining part, 7/11ths times x minus 110. That's what he's left with. Does that make sense? If he loses 4/11ths, that means 7/11ths of the remaining part. 7/11ths of the remaining part is left. Now, then he put 2/5 somewhere else. 2/5, so that means he got rid of 2/5 now. So if you get rid of 2/5, what's left? Right? If you lose 2/5, take away from 5/5, right? One whole, that leaves 3/5. So now I'm going to put a 3/5 here. Again, times, because that leaves 3/5 of his money. He got rid of 2/5. So that leaves 3/5 of times of the remaining money. And donated the 420 that was up. That equals 420. He had that all left 420, which he gave to charity. So there's our equation. Do you see that little equation? I'm going to go to a fresh screen and write that. We have, this is number 3. We have 3/5 times 7/11ths times x minus 110 equals, was it 420? So, let's solve this little equation. Multiply these guys. 3 times 7, 21. 5 times 11, 55. Okay, so do you remember from algebra, how do we solve this thing for x? Well, first off, you got to get rid of this fraction in the front. Multiply by the upside down, 55 over 21. 55 over 21. Okay, so this is part 2 where you have your calculator. So these will cancel out. This is x minus 110. The other side, just use your calculator. You just take 420 times 55 divided by 21. And you get 1100. And then add the 110 to both sides. And I'm getting 1210. That's what he had originally. Okay, so number 4 now. 5/9 of the students at the college live in the dormitories. 5,000 students live in dormitories. How many students are in the college? So 5/9 of the students in the dorm. So 5/9 of is times the students, call that x, of is times in the dormitory. How many are in the dormitory? Equals 5,000. Right? The dorm is 5,000 are in the dorm. So that equals 5,000. So there's our little equation. 5/9 times x is 5,000. So 5/9 x is 5,000. How do we solve for x? Multiply by the upside down, 9 over 5. X equals, that'll be 9,000. 9,000 students in the college. So number 5, on a map, 1/3 of an inch is 6 miles. 19 inches is how many miles? So we just, this is going to be ratio. We'll bring it down here, number 5 down here. Inch, it's good to write down your inches over miles. So 1/3 of an inch is 6 miles. And then 19 inches is X miles. So there's our little ratio. How do we solve a ratio? You cross multiply, diagonal, diagonal. 1/3 X is 6 times 19. That's 1/3 X is, what, 114? Now how do you finish getting X alone there? Multiply both sides by 3. That cancels that 3. And that's 342. So 342 miles apart. Okay, number 6 now. Vonna scored 40 goals. Her success to failure was 4-3. How many times did she attempt? Now, if I write success to failure is 4-3, it's not going to work out because watch the problem. Success to failure is 4-3. She scored 40, so if that's success, right? Then down here I can get failure. I mean, you could do that. That'd be fine. But notice they're not asking for failure. They're asking for attempted. That's different. Attempted means some success, some failure. It means success and failure added together, doesn't it? If I solve this right now, I'm going to get failure. Well, let's do that. Let's just go ahead and keep going. So we're going to get 4 times X is 3 times 40, right? Cross multiply, diagonal, diagonal. So 4X is 120. How do you finish solving for X? Divide by 4. So X is 30. But what is that? X is 30 failures. So she failed. She made 40. So 40 made, right? She made 40 goals, scored 40. She failed 30. So what's their question? What's the number of goals attempted? Add them up, 70 attempted. So that's the answer to the question. You got to be careful to answer the whole question. Okay, so we're supposed to order these from greatest to least. So what I would do is I would write these out vertically. So let me see. So 15.8675, 15.868. Third one is 15.8675. Keep things lined up. The fourth one is 15.86747. Fill in zeros here so that they all have the same number of spots, and you can compare them. Notice they're all the same up to here. They're all 15.86, so that doesn't matter. It's only what comes after that that matters. So who's the biggest? This guy. He's number 1 because he's got the 8. Bigger than the 7. The other ones have 7, 5, right? 7, 5, 7, 5, 7, 4. So he's the last. 7, 4. He's number 4. And then this guy will be number 2. This guy's number 3 because 750 is smaller than 751. There's the order. So you write them down in that order. Okay. Let's try the next one here. So we'll try this one. So again, I'm going to write these guys down. So minus 2.62, minus 2. The second one, 693. Third one, minus 2.623. Next one, minus 2.6023. Okay, we're going to compare and fill in zeros. So now we compare, they're all minus 2.6. That's the same up to there. They only are different afterwards. Now remember, these are negative. So the biggest one is the least negative. Who's the least negative? The least negative would be this guy, number 1, because O is smaller, right? So the smallest negative, right? If you think about negative numbers, like here's 0, here's negative 1, negative 2, negative 3. So the smallest negative is the greatest. That's the greatest number. That's number 1. This would be number 2 and number 3, right? Because, like negative is like being in debt. If you're $1 in debt, you're better off financially than $2 or $3 in debt. right? The greatest is the lowest negative. So the lowest negative is actually the greatest number, number 1, followed by, okay, now here 2 and 2, which one? 2, 0, 2, 3, this one. This one is number 2. He's the lowest, next lowest, and then number 3 is the next lowest, and then this one is number 4, the most negative. So there's their order from greatest to least. Okay, so number 8, write that in scientific notation. Scientific notation means decimal after, scientific notation means decimal after the first digit times 10 to some power. Decimal after the first digit times 10 to some power. So I've got to write 2.2 time, right? I got to put the decimal after the first digit. Now that's not really where it goes. Really the decimal's all the way back here at the end. So if you put it after the first digit, you got to tell it to go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9 places, 10 to the 9th. That's the same. This number and that number are the same number, just written in different formats. This one's normal decimal notation. This one's scientific notation. Okay, so here we are in number 9. We've got these numbers. We're going to order them again. Now the bar means repeat, right? So I'm going to write these out. Minus 3.5, 6, 5, 6, 5, 6, 5. Goes forever. Kind of getting scribbly there. Okay, the next number is minus 3.565, just repeats forever. 5, 6, 5, 5, 6, 5, forever. This next one is minus 3 and then the 5, 6 repeats forever. 5, 6, 5, 6, 5, 6. The next one is minus 3.5, 6, and then the 5 repeats forever. 5, 5, 5, 5. And the last one is minus 3.565. That's it. And just fill in zeros the rest of the way. All right, now again, we're dealing with negative numbers. So the greatest is the lowest negative. So let's see, they're all the same up to here, it looks like. Then they're different. So I'm going to start with the lowest one will be the greatest, the least negative. Who's the lowest? Well, he has a 0. So he's number 1. He's the least negative, which means he's the greatest, number 1. Who comes next? Well, these 5, 5, and 5, 6. This is lowest. 5, 5, 5. 5, 6 is number 3. And then now 6, 5, 6, 0. 6, 5, 6, 5. So this one's lower, number 4. And this one is most negative, right? 65, 60, 65, 65. There we go. I don't know which order that is. On the thing, I'll let you look at that and figure that out.